Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So you can recall that in the last two lectures we had talked about bar diagram, subdivided bar diagram and pie diagram. And the difference between this bar diagram and subdivided bar diagram was that in the subdivided bar diagram you were able to show one more layer of information on the data. Similarly, on those lines, we will continue in this lecture on two types of graphics. One is three-dimensional pie diagram and next is tree diagram or say tree map. So, in this graphic also you will see that creation is very easy, but you will need a separate package for creating these packages, and they will also try to give you similar information but in a different way. So, it will once again depend on you that given the situation, given the data, what type of information would you like to have to represent the facts. So, let us continue with our lecture and let us try to understand how we can create the three-dimensional pie diagram and tree maps. Three-dimensional pie diagram, as the name suggests, it is only a pie diagram, and but there is one more dimension which is added to it. And the use of this three-dimensional pie diagram is the same as in the case of pie diagram. As the pie diagram visualizes the absolute and relative frequency in terms of angles of the segment, similar is the three-dimensional pie chart. They also visualize the absolute and relative frequency. Pie diagram had a segment. A three-dimensional pie chart will have a circular slab which is partitioned into segments where each of the segment represents a category. In the pie diagram there was a circle, and here we will have a circular slab. And it is something like this. If you try to make this circle and try to make it here, this type of slab. And the size of each of the segment, it depends on the relative frequency. So, from center you will have these types of segments over here, and the size of each segment is determined by the angle frequency into 360 degree. Now, let us try to understand how to create this three-dimensional pie diagram. So, for that we need a special package which is called as Plotrix, P-L-O-T-R-I-X, right. So, this package is to be installed using the command install.packages, and then it has to be loaded using the command library. And the context to create this three-dimensional pie diagram is pi 3D. You have to be careful that 3 is a number, P-I-E, number 3 and D. And then you have to give here the data, and then you have to give the labels, and just like as you did in the past. So, let us try to take a very simple example to understand how you can create a three-dimensional pie diagram. And to explain you, I have considered the same data that I considered in the earlier example where we had 10 persons, and they were classified as graduate and non-graduate. The graduates were indicated by number 1 and non-graduates were indicated by number 2, and this data here is given like this, right. And this data is stored in the data vector here, Quali, Q-U-E-L-I. Now, this is here the data vector. From there we have to create a frequency table. So, that we can do using the command here table quali, that we already have done in the earlier lecture also, which will give us that there are two categories 1 and 2 having the absolute frequency 7 and 3 respectively. Now, based on that I use the command here pi. So, for that we have to use here the command pi 3D, and inside the parenthesis it is table quali. And one thing what you have to notice here is that here this P-I-E, they are in the lowercase alphabet, 3 is a number, and D here is capital D, uppercase alphabet, and this is what we get here as a three-dimensional pie diagram. So, you can see here This is not like here a circle like this, but it's actually a slab which has here a height like this, and there are two segments. One is in the blue color and next is in the red color. So this angle which is here, which this is indicating the relative frequency, right? So now if you try to make this graphic more informative, then we can use the same commands that we had used earlier. For example, using here the labels, we can give here the labels like graduate and non-graduate. And if I want to give here the title, you can use here the command here main. And in case if you want to change the color, for example, I want to make it red and blue, so I can use it the command here COL, and I can create this three-dimensional pie diagram. The more important part where this pie diagram is useful is the use of the option explode. What do you mean by this thing? If you try to look at this graphic, what is the difference between this graphic and this graphic? You can see here this slab has been partitioned and this partition has been taken away. Whereas in the earlier graphic, both the partition are stuck together here. So now in order to do it, we use here the command explode, EXPLODE, and this will make this partition separate. The value here is 0.2 for explode, but if you try to increase this value, this distance will become actually more. So in this graphic, all other things, labels, main, color, they are the same as earlier. Right. So let me try to first show you these things on the R console, and then I will try to show you some other example. So let me try to first copy this here data, and before that I have to upload here the library plotrix. Actually, I already have installed this on my computer, so I have to use only the library, otherwise you have to first install it also. So if I try to take it here, simply here Py3D table collie, so you can see here this is here the graphic. So there are two sections here, frozy color and red color, but they are stuck together. But now if I want to make it more informative, then I can use here like this, and if you want to change its color also, for example, instead of here red, I can make it here green, and you can see here this becomes here like this. And in case if you want to use here the command here explode, then you can see here I can just add here this command, say here just to show you here, otherwise I can add it anywhere. Explode is equal to 0.2, and you can see here these two partitions are separated. And I can show you here that if you try to increase the value of this explode, suppose if I make it here 0.6, then see what happens. They are more separated, right? So you can see here it's not difficult to create such a graphics. Now let me try to take here one more example, that is the same example that we considered earlier, where there are 100 customers who visit a shop and there are 3 salesperson who attend them. So this data is like that, let's say first 2 values of 1, 1, they are indicating that the first 2 customers were attended by salesperson 1 and 1. The next value here is 2. So this customer was attended by the salesperson 2, and so on. And this data has been stored in a data vector sales per, right? Now I try to create here the frequency table using the command table over the sales per, and then I try to create here the 3-dimensional pie diagram. So you can see here there are 3 categories. Category 1 has 28, category 2 has 43, and category 3 has 29 absolute frequency. And the same thing is being shown here also. For example, this is here category 1, category 2 and category 3. So, category 2 you can see this angle is maximum among the 3 segments. So, this is indicating that there are 43 values. This angle and this angle, they are almost the same because the frequencies are just 28 and 29, which is very difficult to identify by looking at this graphic only. And similarly, if you want to make it more informative, then now you know it, it is very easy for you. If you want to have the title of the chart, then you need to use the command here main. If you want to create here these labels SP1, SP2, SP3 for this indicating the salesperson 1, 2 and 3, then you can use here the command here labels and give SP1, SP2, SP3 within double quotes inside the data vector. And similarly, if you want to change the colors, then you can use here the command COL, and then in a data vector within double quotes you give the colors green, red and blue, and you can see that the color has been changed. And in this example itself, if you try to use the option here explode, suppose I use here explode 0.3, so you can see here this is the same picture, but now the segments have been divided and they are separated. So, you can see here this is here the separation, right. So, now it all depends on you that what type of information you want to gather or you want to collect from the data. Based on that, you can take a call whether you want to use pie chart or this 3-dimensional pie chart. My objective was to introduce you with both the concept. So, let me try to show you here. If I go for sales person data, then first of all let me try to create here this pie 3D over this table sales person, and this graph will come out to be like this. And now in case if you want to make it here, if you want to make it here, you give here more information. So, you can see here I give you here like this, and if I want to change here the colors, suppose I give here say here gray, say here pink, and suppose here say sky blue, right. So, you can see here that these colors also get changed, right. And now in case if you want to use here the option here say explode, then you can see here if you try to use here explode is equal to 0.5. See here, oh I forgot to put here a comma. So, let me try to write down here 0.5 comma, and you can see here now they are separated, right. So, you can see here it is not a very difficult thing to create such a 3-dimensional say this pie diagram, right. Now, let me try to give you here one more example from the same data set printed from the library mass, which we have used earlier also. So, we will upload the library mass, and then you can using the command call names, you can find that there are 5 variables composition, drawing, color, expression, which were quantitative, and 1 variable here is school, which was qualitative. So, there were painters who are coming from this from one of the 80 schools A, B, C, D, E, F, G, H, whose data is here like this. And now you can find out their absolute frequency using the command table over painters $school, or their relative frequency using the command table within parenthesis painters $school divided by length of painters $school, and you will get here the relative frequency. Now, based on that, I try to create here the 3-dimensional pie diagram. So, you can see here pi 3D over table painters $school will give you here this type of graphic. Now, I try to make this 3-dimensional pie diagram more informative, and now I try to separate the segments. So I use here the command explode is equal to 0.3, and then I give here the title of the curve using the mean. Then I try to give here the labels A, B, C, D, although I am taking the same, but you can make it different also using the command here labels, and I try to change the color of the segments by using this command COL as red, green, orange, pink, yellow, blue, gray, sky blue, and they are all within double quotes inside a data vector using command C. So you can see here you will get this type of graphic, and you can see here this is more clear graphic, but let me try to show you these things on the R console also. So first let me try to upload the library here mass, and then I will try to use here this Py3D diagram over the school variable in the painters data set. You get here like this, and if you really want to make it more informative, you can get here like this. Right. So you can see here it is not a very difficult job to create such a three-dimensional pie diagram, and it is very easy to control their characteristics by giving different types of options. But for that, I would request you to look in the help menu and try to see what you can do. Okay, so now after this we come to one more type of graphic, which is called as tree map. So as you had actually seen, if you try to recall, we had created two types of graphics, bar diagram and subdivided bar diagram. What was the reason? Because in subdivided bar diagram, we had one more layer of information which can be presented through the graphic. Right. For example, we had taken the example of shop 1, shop 2, shop 3 and the number of customers on day 1, 2, 3, 4, and we were also able to create a bar plot where each of the bar was subdivided like this. So that was also giving us an information that how many customers have visited the shop on a particular day. And this chart, tree map is an alternative to pie chart. Pie chart can handle only one variable at a time, but if the variable has more layers of information or more levels of information, then pie chart cannot handle. Right. So pie chart cannot handle if the variables have many levels, but tree maps can handle. Right. So what's a tree map? Actually, tree map uses rectangle sized by numerical values to represent the categories. Right. You will see that it will be something like a rectangle where different rectangles or different sizes, they are indicating the numerical values. And actually, this tree map is used to display the hierarchical data as a set of nested rectangles, and each group is represented by a rectangle which area is proportional to its value. How it is done, I will try to show you by a very simple example. Right. So this tree map is a space filling visualization of the hierarchical structures, and this function offers a great flexibility to draw tree maps, and the requirements are we have to give the input data in the format of data frame that contains one or more hierarchical index column and which are specified by index. You can recall that we already have discussed about data frame, and there will be a column that determines the rectangle area sizes, which is given by V size, lowercase v, capital or say uppercase S, IZE in lowercase. And after that, optionally, a column that determines the rectangle colors. So that is given by V color, lowercase v, uppercase C and OLOR in lowercase. And these rectangles are colored based on the argument type TYPE. So the way we are going to use the command for tree map is like we will use the command TREE MAP all in lowercase, then the data frame, then index, then V size, then V color and then type and so on. There are other options also, right. So DTF is indicating the data frame, index is going to be a vector of column in this DTF that is specify the aggregation indices. Right. V size is the name of the column in the data frame that is specify the size of the rectangle and it is required. So, index is needed, V size is needed. V color will provide the name of the column that in combination with type determine the color of the rectangle. And type is the type of the tree map which determines how the rectangle are colored. So, how to get it done? Let me try to give it by a very simple example. So, in order to explain you this concept, I will try to create here a small data frame in which I am trying to take here 3 data vectors. One is about state, other is city and other is say students. For example, if I try to show you here, it will look like actually this, right. This is here UP, 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 UP in which there are 5 cities Lucknow, Kanpur, Agra, Noida, Ghaziabad. Then I take one more state MP, MP, MP and its cities are Indore, Bhopal and Ujjain. Then TN, TN, Tamil Nadu, which has only from where we are taking 2 cities Chennai and Kanchipuram. And based on that, if you try to see, I am giving here the values or the number of students. Okay, these are certain hypothetical values. Lucknow has 1000, Kanpur has 900, Agra has 800, Noida 700, Ghazia 600, then Indore 550, 450, 350, 200, 100. So, if you try to see, I have given this number intentionally such that they are decreasing, right. So, in UP all the numbers are separated by 100 values, in MP all the numbers are separated by 50 values and in Tamil Nadu 2 values are separated by 100 units, right. Actually, this will help me to show you what exactly I want to retrieve from the tree map. So, you can see here one level of variable is say state and within a state there are cities and in every city there is some number, some frequency, some value. So, if you try to see, we want to capture this information. So, we try to give this data in the form of 3 data vectors here like this and we try to create here a data frame. The data frame is created by the command data.frame, data.frame and inside the parenthesis I will write state, city, student, which is state, city and here is students. And I save this data frame as DFTREEMAP. So, that is data frame for tree map. This is how I am calling it, right. So, this data frame will actually look like this. So, you can compare here actually that this is the same thing. These are the states which are here and then you have here cities which are here and then finally, in the third column you have here number of students and which are here, right. So, we try to first install the package tree map using the command install.packages and then upload it using the command library tree map. I already have installed this package on my computer. So, I will use only the library tree map and if you try to use the command here tree map and then the data frame in which you have given the data, then index is equal to state, V size is equal to student. So, index is trying to show you here that how the values in the first column they have to be clubbed together. So, you can see here if I say there is one state, but a 5 data set for UP, one state MP with 3 data set and say another state Tamil Nadu with 2 data set, right. And if you try to find out the total frequency of UP, MP and Tamil Nadu, if you try to sum these values in the UP, this will be 4000 and 3 values of MP, this will be here 1350 and 2 values of Tamil Nadu, they are 300, right. So, I am trying to say here the command here index is equal to states. So, that means states are going to be clubbed together and then I try to give here the V size. V size is in double quotes name of the variable or the values which I want to plot. So, I am giving here students. So, students are here in the third column. So, you can see here the number of students in UP is 4,000, in MP 1350, and in Tamil Nadu 300, which is written here. So now if you look at this map, there are 3 rectangles, 1, 2, and here 3. Now if you try to see, the rectangle number 1 in blue color is the largest, and the rectangle number 3 in pink color, that is the smallest. Now if you try to see what they are trying to indicate, they are trying to indicate that UP has the maximum frequency. Maximum frequency is here, this here 4,000. 4,000 students are here. Similarly, in MP, there are 1350 students. And in Tamil Nadu, there are only 300 students. So if you try to see, this tree map has combined the information on actually the states, and it has combined it, that it has found the total frequency, and it has given all this information inside this graphic, and the name of the variable here is say students. So by the option index, it is trying to aggregate the variable which have to be clubbed together, and because there are 2 more columns, say cities and students, so it is trying to tell by V size that which of the values are to be aggregated. So the tree map has aggregated the total number of students across 3 states, and it has plotted them in the form of rectangles, and this is called here as a tree map, right. So this is how it will actually look like, but let me try to show you this on the R console first, right. So this is here like the, so let me first try to copy this data and try to create the data frame. Let me try to first clear the screen so that I can create a new graphic. Right, so if you try to see here this DF tree map, this data frame looks like here this, and then now I try to upload the library tree map, and now I will try to create here the tree map. And you will see in the help that there are many other options which can be used to make it more informative. You can see here, this is here the tree map, right. It is not difficult at all, and you will now understand that what type of information it is giving you, which possibly pie diagram cannot give you, right. Pie diagram at the most can plot only these 3 figures, 4,000, 1350 and 300, that's all, right. But it cannot automatically compile that this 4,000 is coming from 5 data points, 1350 is coming from 3 data points, and 300 is coming from 2 separate data points, right. Now, let me try to give you here one more example which is a little bit complicated. Complicated in the sense that there are many variables and a big data set. So this is a built-in data set inside this R software, which is actually here business, BUSINESS, which is actually a fictitious aggregated business statistics data set. And here there are index variable NACE1, E1 to NACE4, which are actually derived from the statistical classification of economic activities in the European community. And there are variables like turnover and say employees, which have values for NACE codes in the business economy domain only, and it has 603 entries in 9 columns. And this has been taken from this reference, statistical classification of economic activities in the European community, Eurostat, structural business statistics, right. So my idea is only to show you that how the tree map will look like for when you have more number of variables and more data sets. So this is the data set. I will show you that you can see yourself, which is built in the R software. Now, if I try to make here this tree map for the business data, index are NACE1 to NACE2 to and NACE3, and V size here is turnover, and then type here is index. You can see here it looks like a little bit here complicated. You can understand it if you try to understand this data and then try to see here, but now you can see here many things are written over here, and the different type of information is here. So this is actually a tree map which will help you in getting more information. But for me actually the thing is this, I want to show you here that many times, and I want to remove the fear from your heart, that many times if you look at the graphic, they look very complicated, but if you try to plot them, they are not that difficult. So you can see here, this is here like here view, this business, it will look here like this, right? You can see here there is a lot of data here, right? I'm not going into the details, but I will simply try to plot this tree map for you, so that you can understand that it is not easy, it's not difficult actually to make such graphics, and it is very easy, right? So you can see here, this is here the graphic, right? If you try to increase it, it will become a good value like this one, right? So now we come to an end to this lecture, and you can see here that we have taken here two very simple topic, 3-dimensional pie diagram and tree map. But now as we are moving forward, you can see that whatever data I have considered up to now, that was in the univariate data only. But different types of graphics, whether it is bar diagram, subdivided bar diagram, 3-dimensional pie diagram, this tree map, they all are trying to give you a similar information, but in different ways, and they are trying to represent different types of data. Different types of data can have different types of information, which is your decision that which of the graphic you would like to use, which can give you the correct and true information. My job here is to give you an idea about the availability and the basic concept behind these graphics. But when you will be working with the real data in real problem in your area, then it will be your decision that what I want to use, and there will be different option to modify or customize your graphic. It will be your choice how you want to do it. So I would request you, try to create some data set yourself. When you try to create a data set yourself, then you can understand what is happening. For example, I have created here a data set on states, cities and students. Very simple data set, but if I try to change the values, then I can compare that what is happening in the graphics, and I will get more confidence. And similarly, try to take this bigger data set, built-in data set, and try to see what was the nature of the data and what are you getting. Because anyway, you are going to work with data science, where the data size will be huge, and maybe the number of variables are also pretty large. And once you want to dig out the hidden information, you will have to experiment with different types of combination, different types of graphics to understand what the data is trying to tell us. So you try to practice it, do some example, and I will try to see you in the next lecture. Till then, goodbye.